Hey guys, real quick, there were a couple of problems, of mistakes rather, that I made on the last couple hard questions on the homework. I wanted to go over them really quick. So, I apologize, by the way. It's really late. I was just thinking about it, and I looked back and I saw that there were a couple of mistakes I made, so I wanted to fix this before I go to bed. Like I said, it's really late. Not firing at 100%, I apologize. So I wanted to really quick go back and make these two corrections. So in 12, we ended up getting this number for our initial velocity. It's pretty low, and the reason for that is, if I find the Domino's plate that I did this math on. Here we go. So in 12 here, I said that for the last part we can add together this distance plus this distance for it, which is true. I did say that. However, the problem is, the question says when the chestnuts fall in 2.5 meters, you throw the second chestnut. So I was assuming that we drop them at the same time. So this part that I did here where we add up all of the stuff and we get another 0.7 seconds, so we get a total of 1.4 that we have to use for the last calculation, that we don't need to, because it doesn't actually have to fall this distance, it just falls during this period of time when it's falling here. So we actually just use 0.7 for our t there, and if we do the math exactly the same. The only difference is that this, instead of being 1.4, is 0.7. So that's 0.7, and then this over here, this 1.4, that's 0.7. So all of this math gets changed because of that, and the answer ends up coming out to about, if you just do the math correctly, the answer comes out to about, like, not negative 0.028, but negative 10.5 meters per second. So the rest of this is fine. The rest of that one is fine. The only difference is that I assumed that we were dropping it from the same type. I didn't read this part of the question, so that ended up being wrong. And then I made a mistake in 13 also. Sorry, like I said, is pretty late. I made a mistake in 13 as well. And the mistake that I made in 13 is the man doesn't start with a distance of +6. The bus starts with a distance of +6. So this 6 is not over here, it's over here. So in our math over here, all this is fine, except that's not a +6 on this side. It's a +6 on this side, which makes this 6 negative over here. And let me just double check really quick what that is in my quadratic formula calculator, but it's going to be way different. That's -6. Yeah, so we end up getting not t equals 7.9. We get t equals 2.28 seconds. Alright, so here's the deal too. I just want to tell you guys this. So the reason that this 6 goes on the bus's side is if we think about our positioning. And this is, I say you should always draw a diagram so that this sort of thing doesn't happen, and I did it this time. So we got our dude here. He's running after the bus. The bus starts here. The bus is 6 meters away from him when he starts moving, right? So that means that his position is 0, and the bus's starting position is +6. So this +6 has to go to the bus because the bus is starting 6 meters downwind. I was thinking like he's 6 meters away, so we got the 6 to his side, but it has to get out into the bus's side, which of course will make it negative when we move it over. But aside from that, the rest of this math is fine too. Just the specific deal of me putting the +6 on the wrong side. So sorry about that. These are the corrections. Make sure that you watch this video before you actually do 12 and 13. But those are the only mistakes that I made, I think. I think the rest of this is fine, as far as I can tell. Before one of you in school tomorrow was like, hey, Mr. McComb, you're stupid, and you did all of them wrong. But I don't think I did. But anyway, thank you guys for watching. Have a good day. I'll see you later. I'll see you in like 2 hours, actually.